Okay, so today we're going to look at absolute values. And before we get into the actual graphs of these absolute values, I want you to think about what absolute value means. If I asked you to take the absolute value of a number, what exactly would that mean to you? For many, they don't think of the definitions, distance from zero, or they don't think about what, I guess, it in essence means mathematically, but they think about the fact that it just makes the thing positive. So I want you to think about that concept as we look at these graphs. See, because as we look at y equals the absolute value of sine x, what does that mean to the graph when we're saying, okay, I want you to do the absolute value of that entire graph? We understand that the sine curve looks like so, but what does it mean when you take the absolute value of it? And of course, this means, if we were to read this as its meaning, it means y equals the positive sine of x. That means that it is always positive. And so in our graph, it would reflect that by simply saying, instead of, see, this is positive, so instead of this section here that's negative, what would happen is it would bounce. And if we were to keep drawing the rest of sine, it would continue to bounce in both directions and just constantly be hitting at those integer values of pi. And so that's how that would fall into place. Now let's look at the next one. What does that mean for a line such as 2x minus 5? It helps to know what that original graph actually is. So let's just do that relatively quickly. The y-intercept being -5. The x-intercept would be at 5/2 or 2.5. So this is what it would look like. So that would mean then that any of your y values that are negative would become positive. So this section here that happens to be below would no longer be there, but instead we would have 5/2. That part stays the same, but this section that was below would bounce up and become positive. So instead of crossing at -5, it would cross at +5. Okay, let's look at the next one. The next one is a parabola. So how would that affect a parabola? Again, it's helpful to know what the original graph looks like. We can tell from this that it is crossing at -5. Its roots would help if we actually factored that to be x plus 5 and x minus 1, so it crosses at -5 and +1. And so here's what my graph would look like. So once again, what's going to happen to our graph, the positive sections, the part on this side of 1 and this part of -5, those are going to stay the same. Those aren't going to change. But what's going to happen is this bottom part, where the y's are negative, are going to bounce and become positive. And so the y-intercept, instead of being -5, again, would flip to be +5. Does that make sense? So it's making the y values positive. So how does that affect it when we're talking about x having just the absolute value around? See, now this is a different thing. You'll notice I actually have already written the rule up here for you. And so if you can keep this in mind, and hopefully it'll make sense as we do these, what happens is x's, think about this in terms of absolute value, we're saying the x's are staying positive. So what will happen is when the x's are negative, they will take on the same value as the right-hand side. So whatever the value of the positive x is, that's what the other side will look. Let me just demonstrate that for you. We've used sine x throughout this little thing, so let's use it again. So if I have the absolute value and I'm looking at the left-hand side, remember the right-hand side won't change because that's where x's are already positive, so it won't affect that at all. What happens to this if we're looking at the negative values, at -pi and -2 pi, is this. Again, your right-hand side will stay the same because that's where the x's are still positive. Instead of when we look at -pi, okay, we're going to do the absolute value, so it would take on the same as regular pi. Or if I was to look at sine of -pi/2, we would simply drop that absolute value, indicating it's taking on the same value as +pi/2, and it would look just like that. And so this would be -pi and -2 pi, and it would continue to look like that. Lovely little mustache there, right? Okay, so let's look at another graph. Y equals x² minus 2x. It does help to know what the original graph looks like. So let's just do a quick little, this one's going to cross at 0 and 2, and if you don't believe me, go ahead and give it a whirl. And so it has the point 1, negative 1. That's what the graph looks like. So when I do the absolute value of x, now this is the cool thing, the right-hand side would stay the same. So starting at 0, that part would stay the same. The left-hand side would take on the same values as the right-hand side, and so it would look just like that. E to the x. Let's look at that one. Again, we know what that e to the x graph looks like. That's what it is, right? And so when I do the absolute value of x, the right-hand side would stay the same. The left-hand side would take on the same values as the right and would look as awkwardly as that. Looks like a parabola, but the truth is it's just the e to the x split into the two pieces. And so that's absolute value of x and absolute value of the entire function of y. Keeping in mind, when we're talking about the whole function having the absolute value, it bounces. When we're talking about just the x, it simply keeps the right-hand side the same, and the left-hand side looks just like the right.